Okay, I just asked you to draw the unit circle out for the first quadrant. Give me a second here. Okay. So so it started at 0 degrees, which is 0 radians. What's the coordinates for it? 1, 0, 1, 0. Good. 30 degrees. How many radians?
5/6.
5/6. Coordinates? Good. 45 degrees? 5/4. 5/4. 60 degrees?
5/3. 1/2.
90 degrees?
5/2.
0. Okay. Get that? You nail that? And then everything around is the exact same coordinates with just negatives. Okay? So, again, do it again tomorrow. Write out that first quadrant. Just get it hammered down. It's because as we get going, we're getting to what we call trig identities, and we have to find special angles, like the sine value of 15 degrees, or the sine value of 105 degrees. In order to do that, we need angles like 60s and 45s, and we have to add them together. Okay? So you need to know these values right here, those exact values. We need to know them as, like, they have to become second nature to you in order for it to be a lot easier as we go ahead. Okay?
So when you flip it over to like the second quadrant, how does the does it stay to the reference angle of?
Yes.
Okay.
Yes. So, for example, up here, 120 degrees, right? What's your reference angle there?
60.
60, so it's the same as the 60 degree. So this is 2 pi over 3, right? So it becomes -1/2 and root 3 over 2, because the x value is negative. So it just stays the same. Okay? And it works the same way all the way around. Just make sure you know your reference angle, and then you go from there. Okay? Alright. Go to page 130. I went through this yesterday, and I'll go through it again today, because again, you're going to see this a few more times. Actually, I went through all of it, didn't I? So let's do a quick review of, let's do the first example. So I suggested that you draw triangles for this, because it just makes everything easier. So I've got point A is -12/13 and 5/13. So which quadrant is it in which x is negative and sine is positive? Okay. So that goes up here. Again, all angles made with this. Okay. So the x value of that coordinate is the cos value, correct? So what's the cos value? -12/13, right? Which then means that this guy is 5. Okay? So what's the sine of theta?
5/13.
5/13. What's the cos of theta?
-12/13.
What's the tan?
5/-12.
What's the cosecant value?
13.
13 over 5, very good. What's the secant value?
13 over negative 12.
Yes, and the cotangent value?
12 over 5.
Okay.
Why isn't the 13 negative?
Why isn't the
'Cause you
13
squared.
negative?
Oh, yeah.
Negative 12 would be positive 1.
That guy's always going to be positive. Right? Okay? Oh, actually, no. I'm going to answer your question differently. It's written like this, right? So
Yeah.
your question is, why is the 13 non-negative? Yeah, okay. That's a good question. This, and this all mean the same thing, right? As long as one of them is negative. You can't have both or it becomes positive, correct? So they all mean the same thing. So you have to identify which one you want. Well, when you're doing this, and you do a squared plus b squared equals c squared, this guy is always going to be the positive value. Okay? So it doesn't matter if I write it in front, on top, or on the bottom. It all still means the same thing. Okay? So far, does that make sense from yesterday? That was the easy part, right? Okay. And the next thing I asked you yesterday was the cosecant of 5 pi over 4. Cosecant is the reciprocal of which one? Oh. Sine. So what am I asking you for? 1 over the sine of 5 pi over 4. What's the sine of 5 pi over 4?
Isn't that 225?
But that's how I'm asking you. Okay? I'm asking you what's the coordinate? What's the y value of the coordinate at 225?
The y value?
Yes.
Negative
Negative 2.
2 root 2 over 3.
Yes. Just like that. So the answer is this. That. Remember the pi over 4s are all root 2 over 2s. All the pi over 4s are all root 2 over 2s, right? So it's just a case of finding which quadrant it is and whether the x or the y is positive or negative. Okay? So far so good. All right. I didn't do example 3 yesterday, so let's do it right now. And these are the money questions here. These are the questions that are going to cause some work. All right. And you see these things repeatedly, these particular questions, okay? And we have to know how to do them. So I'm going to start a little bit different here. I'm going to start with, how do I make this make sense? Actually, you know what? Let's just go with this. We know what we're doing. Okay. It says they want you to find the secant of theta where the ratio is root 2. So I want over a domain okay. So what is the question asking me? For what angle of theta, for what measure of theta, does the secant theta equal root 2? Okay, that's what it's asking. So where have we seen this before? What have we done in this before? You guys need to really pay attention because you're half asleep here. Where have we done this? Where have we seen this? Well, all along I've been asking you, okay, find me the angle of cos theta if I have 4 over 5 as my ratio. So we would draw our triangle. Theta would be right here. This would be 4. This would be 5. And I'd ask you what theta is. How would you solve for it?
Find the opposite side. Like the
No. I just need to find the angle. How would you do it? Grade 9 right triangle trig. How do you solve this?
Isn't this second function cos?
Yeah, that's it, right? Take second function cos of 4 divided by 5. And you would get an angle, correct?
Yeah.
Okay, so what's different now? Well, now we've discovered that there's more than one angle with the ratio of 4/5. If you go around that circle, there's going to be 2 spots on the circle where it's equal to 4/5. So let's use a bit of a more simple one that we should know. Okay, so sine theta is equal to 1/2. So what angle is the sine ratio equal to 1/2? 30 degrees. So we knew that. We punched that into our calculator when we were grade 9 and we solved for it, right? But now you know that actual answer because we've done the work with the triangle, so we got that. But there's also another angle. What's the other angle that has the same value of sine theta equaling 1/2?
390.
No?
No, 300.
Well, it is actually 390, yes, okay, but not the one I'm looking for.
330.
No? Between 0 and 360, guys.
Oh, negative 210.
No. Okay, so let's go back to grade 11 applied for a second here. Okay? Or grade 11 pre-calc. We did it both. You guys were listening to this the last 2 weeks with these guys. The sine ratio has, when we did the ambiguous triangles, where you'd find a triangle whether they had 0 triangles, 1 triangle, 2 triangles, right? You would find the angle, and the first one would be an acute angle. How would I find the second angle? You remember? Hey, doing ambiguous triangles, right? So I've got 2 triangles, and I found my first angle, 30 degrees. How did I find the second angle? Supplementary. What does that mean? From? 180. So that's what just happened there. Okay, pretty good. So that's where. Okay, so what's my other angle?
150.
Sine of 150 and the sine of 30 gives me 1/2. Okay? Now, when you look at your unit circle, when you go all the way around your unit circle, there's 2 spots on the unit circle where your ratios are always the same. Okay? In quadrant 1 and 2, your sine ones are always the same. Right? In quadrants 1 and 4, your cos ones are the same. Okay? So what I'm saying here is this. Theta equals 30 degrees. Theta also equals 150 degrees. Right? Have your unit circle beside you, please, and look at it. The copy I gave you, not yours. Look at it and find out where sine theta equals 1/2. Where your y value is equal to 1/2.
150 and 30.
And 30, you agree with me? So you see that there's 2 possibilities, correct? Now, back to what Marshall said. He said 390. The domain they want you to find it for is not just between 0 and 2 pi. It wants you to go around the circle one more time. So he was absolutely right. 390 is another one. What's one more? 5, 10?
Yeah.
Yes. 360 plus 150, right? So then that would give it to me. Okay? Now, we're understanding this before I get into the actual question itself. You follow what I'm saying here? Okay? So here's what's happening. This might make more sense now. Okay? Now, where do we add on to this? Where do we add on to this? Well, we add this reciprocal ratio. So what am I looking for? We're secant theta is equal to √2, or where cos theta is equal to 1/√2. Trin? Right? So I want to know where on the circle is cos theta equal to 1/√2. Well, what is 1/√2 if I rationalize it? √2/2. Times the top and the bottom by √2. right? So where, looking at your unit circle, is your cos theta equal to root 2 over 2?
45 degrees.
And
315.
do we agree?
Yes.
Where is the x value a positive root 2 over 2?
Yeah.
Is that what they are? Okay, I got a problem with that. Look how my domain is written. What am I looking for?
2, 3, 4, 5.
Oh, in radians.
In radians. So what is the correct solution for this then? Theta equals
Pi over 4.
pi over 4,
7 pi over 4.
7 pi over 4,
9 pi.
9 pi over 4,
And 15 pi.
15 pi over 4. There's your solution. Okay? It doesn't make it any more confusing because you have radian measure. Because you have the radians written right beside your degrees. So it doesn't make it any more confusing. Alright? So what I'm understanding now is that I have more than one angle that has the same ratio. Got it? Okay. The second one is a little more complicated. For a couple of reasons. So what do I have? Cosecant theta equals, is it cosecant or secant? It's cosecant. Negative 1.5557.
Yeah.
All right. So what am I actually looking for? Where is the sine theta ratio equal to 1 over negative 1.5557. Okay. All right. Now, this value is not on the unit circle. Okay? So I'm looking for two ratios, though, two angles that have this same ratio of 1 divided by negative 1.5557. So here's how I set this up. I want you to watch, because this is, again, there's so much of this stuff we have to do over and over and over again, and you need to hit the basics. So what I'm going to do is I'm going to find out the first angle that theta is equal to this ratio as a positive. Because that's in my first quadrant as a reference angle. So take out your calculator right now. Now again, what was the domain given to me as?
Degrees.
In degrees. So make sure your calculator is in degrees this time. And I want to find out my reference angle in the first quadrant. So this has to be a positive. So second function sine of 1 divided by 1.5557.
40.
What'd you get?
40.
Right on the nose?
40.007363.
Okay, well let's go to 3 decimal places. 40.001
0,
degrees. Alright. So there's the first quadrant. Alright? That's my reference angle. Now that sets me up easily for the next two quadrants. Where is sine negative?
Quadrant 3.
And?
Quadrant 4.
Very good, Zach. Okay? So what's the angle in quadrant 3 that shares that ratio?
220.001.
And in quadrant 4?
319.999.
Right? This quadrant, reference angle plus 180 degrees. This quadrant, 360 degrees minus your reference angle. We've done that. We did that last year. So far, so good. But what's my domain? So I found between 0 and positive 360, correct? So how do I find the negatives of those?
Isn't it same?
No,
But no use. Right?
no, yes. Subtract 360 from both of them, right? So right now I went from here to here, correct? So to find the negative, I go that way. So subtract 360 from it. Third quadrant, yeah. And fourth quadrant, negative 40.001 degrees. Now let me show you one quick thing. Punch into your calculator right now the second function sine of 1 divided by negative 1.5557.
Negative 40.
Right there. It'll give it to you every time. I don't show you that.
What did we just type in?
This. You got negative 40? Yeah. Okay, it works for sine, it doesn't work for cos for the record. For sine, it works like that. But for cos, it doesn't. Okay? So do we understand now a couple things? Number one is that a trig ratio has multiple angles that share the same ratio. Okay? We understand that? So in order to find them, if you're using your unit circle, if it's a value on the unit circle, then just go find it. You don't have to do any more work than just this. If it's not on your unit circle, then you start by finding your reference angle first, and then find out which quadrants satisfy the ratio. Okay? Now, this can be extremely easy, this section, but it can also be extremely difficult. So you need to find your happy medium in there and then find out what it takes to make it very easy. Triangles make it easy. Alright? And triangles make a lot of other things a lot easier too. Take a look at trying to figure this out here. There's just some notation that they want you to understand too. So I'm gonna, if you see this, that notation means this, that the point on the unit circle, the point, lays or lies, whatever you want to say, at pi over 3. So what they're looking for then is the cos of pi over 3 and the sine of pi over 3 when they write that out. Okay, so that's new to you. Twice. Write it down. It's new to you. Okay, so then if that's the case, on your unit circle, that value's right there, right? It's pi over 3. What's my ratio? What's my ratios or my exact values or my coordinates? So when you see this, it's looking for that. Okay? You haven't seen that yet? It's new?
And that's all it wants for you.
That's right. Okay? Alright, were there questions from yesterday? I wanted you done 4.2.
Yeah, page 146, 5C.
Okay, So actually, I think I fixed that already today.
Okay, so it's just root two. So negative root two over
Yeah.
two.
This particular workbook, we'll write it as 1 over root 2. But a lot of the other workbooks and the textbooks that I've used in the past and the exam, we'll write them as root 2 over 2. So I want you to, so all that is I, remember what I said, I rationalize that?
Yeah.
Rationalizing means getting rid of a root on the bottom. So I times it by root 2 over 2 and root 2 over 2, which gives me root 2 over 2. Okay? So that's, does that answer your question now? Okay, other questions from yesterday?
How you do 7A? 1.7.
So you've got, what's the radius? Did you find the radius or do you know the radius? The Earth moves in a roughly a circular orbit around the Sun at a distance of approximately 150 million kilometers. To estimate the longer distance in space, scientists must.
So that 149 million is the radius, isn't it?
Well, 150 million would be.
Okay.
So all it is x squared plus y squared equals 150 million squared.
Oh, okay. It's just a lot of numbers.
Don't worry about that question. We're not gonna do that question again. Okay. If you got 5 and 6 done, then get on that 4.3, go to it. That's more of the questions that we need to focus on going into an exam. Okay? Again, page 128. That's another example of your unit circle. Blanks, unit circle. So again, write out that first quadrant each day until you master it. Okay? Other questions this morning?
Maybe we want to